Hello students. So in the previous classes we finished Newton's first law and Newton's second law, and we saw numericals on Newton's second law also and its derivation. So let's start with Newton's third law of motion. So it's the easiest and many students mostly write, if any of the law is asked, they always write Newton's third law of motion. Why is it so? Because it is so simple to remember. What is the statement of Newton's third law of motion? Every action has an equal and opposite reaction. Pretty simple to remember. Every action has an equal and opposite reaction, or action and reaction always come in pairs. So let us see certain examples in daily life through which Newton's third law can be explained. See, when a person is sitting on a chair, okay, a person is sitting on a chair, then what happens that the weight of the person is acting downwards, mg, okay, and we've studied about balanced forces and unbalanced forces. So there's a force which is acting downwards, the gravity is pulling it down. But why isn't the boy falling on the ground, or why isn't he going towards the center of the earth? Because of the pull of the gravity. That means if the person is not moving, that means there is an equal and opposite force which is balancing this force downwards. So what is that force? That is the normal reaction of the chair. The chair is balancing the boy, and the chair is exerting an equal force in the opposite direction. Both these forces are equal in magnitude and opposite in direction. That is why they cancel each other, and the boy isn't moving. So we can say that for every action there is an equal and opposite reaction. Imagine the same boy sitting on a cardboard box, a carton, right? So it's the boy who's quite heavy, and he's sitting on a carton box which is empty. What will happen? The carton will or the boy will go inside, or he'll fall. Why is that so? Because the carton is not able to apply the reaction force equal and opposite to the weight of the boy. That's why the boy will fall down. Okay? So whenever there is a force, there is a reaction force as well. So in the Newton's first law we studied that what force can do. What force can do? Force can bring about change in the state of a body. Force can stop a body, force can move a body, force can change the direction of a body, force can change the shape and size of a body. This is what force can do. That is described by Newton's first law. What do we know, come to know by Newton's second law? How can we calculate force? Okay, force is equals to mass into acceleration. So how can we calculate force? How much force is applied on a body? That can be calculated by using Newton's second law. And Newton's third law says that whenever there is a force, there is a reaction force also. Okay, so action is always equal to reaction. You can never say which force is acting as an action and which force is acting as a reaction. Like for example, when a swimmer wants to swim, he wants to start swimming, what he does, he pushes the back of the wall, okay, of the swimming pool, and because of this is the swimming pool and the swimmer wants to swim, so he exerts a backward push on the wall, and then because of that backward push, the wall pushes him forward and he is able to move forward and he is able to start swimming. Okay, similarly the birds which are flying in the sky, when they flap their wings, they exert a downward force, okay, and the wind exerts an equal and opposite upward force, which is why they are able to land in air and fly easily. Okay, so these are few examples of Newton's second law of motion. There are many more examples, like for example when you play with a ball, when you bounce the ball, when you hit the ball on the ground, what happens? The ball comes back. It is bounced back. When the ball moves when the ball is pushed downwards, your force pushes the ball downwards, and the reaction force of the earth when the ball hits the ground, the reaction force of the earth hits the ball backwards. Now the next question comes, why isn't the earth, if the forces of the ball and the earth are equal and opposite, so the earth is able to bounce the ball back, why isn't the ball able to move the earth? Okay, so let's see that. So when the ball hits the ground, this is the ball for example, and this is the earth. When the ball hits the ground, the ball exerts a reaction force. Let us say, we can call any force as reaction or action. So the force exerted by the ball is, let us say, the action force, and because of this, according to Newton's third law, the reaction force is exerted by the earth. Okay. Now, if according to Newton's third law, both the forces are equal in magnitude and opposite in direction, then because of this force exerted by the earth, the ball goes back, it bounces back, comes to you. Why doesn't the earth go down? Because of the same magnitude of force exerted by the ball. That can be explained by Newton's second law. Newton's second law says that force is equals to mass into acceleration. Okay. So let us say that force of the ball is equals to m1 a1. Okay. Mass of the ball, acceleration of the ball, and force of the earth is equals to m2 a2. Mass of the earth and acceleration of the earth. Now both the forces are equal in magnitude, so we can equate m1a1 to m2a2. Okay. Now you already know that mass of the earth is much greater than mass of the ball. Okay. That means m2 is very high than m1. So if I write that a1 upon a2 is equals to m2 upon m1. Okay, I can write this a1 upon a2 is m2 upon m1. Now look at this ratio, m2 upon m1, mass of the earth is 6 into 10 to the power 24 kg. Okay, it's very high, and mass of the ball must be some grams, right? So what will be this ratio? This ratio will be approximately equal to infinity. That means very high. That means if this is equals to a1 by a2, that means a1 by a2 is also very high. Very high. That means if you take this a2 above, a1 is much greater than a2. What is a1? Acceleration of the ball. What is a2? Acceleration of the earth. Okay. So since mass of the earth is very large, its acceleration is very small. Okay. And since mass of the ball is very less as compared to that of the earth, so acceleration of the ball is very high. That's why though the forces are equal in magnitude, their accelerations are opposite to their masses. Lesser the mass, more the acceleration. Remember this. If mass is less, acceleration is more. If mass is more, acceleration is less. Vice versa. From here also you can see force is equals to mass into acceleration. So acceleration is force upon mass. Okay. Greater the mass, lesser the acceleration. Lesser the mass, more the acceleration. Inverse proportionality between acceleration and mass is there. So that is why the ball is bounced back due to the earth's force, and the ball is not able to move the earth by an equal magnitude. Okay, I hope now you must have understood. There is a very ancient and nice example given in your book to explain Newton's third law of motion, that is recoiling of a gun. What is recoiling of a gun? I know most of you must have tried shooting also, and you know, and if not the proper shooting, then most of you must have tried shooting in your fairs where you shoot those balloons. Have you ever tried? So if you shoot it, then you know that whenever you shoot from a gun, if there's a gun and you try shooting from a gun, okay, this is the gun, and if you try to shoot from a gun, when the bullet is fired from the gun, what is the acceleration of the bullet? It's very high, right? And when the bullet goes forward, have you experienced a recoil, an opposite force on the gun with which the shooter also gets a backward jerk? Of course, you must have experienced. So, when the bullet goes forward with a force, equal and opposite force is given back to the gun. That is known as recoiling of a gun. Okay, what is this called? Recoiling of a gun. So now let's compare the masses of the gun and the bullet. Whose mass is more? Mass of gun is more than mass of bullet, right? So we know there's an inverse relation between them. Therefore, acceleration of gun will be less than acceleration of bullet. And that's true also. You must have seen that the acceleration, the velocity with which the bullet goes is much higher. The bullet can go and kill a person. And with the same force, the gun is recoiled back. Though, if not handled properly, due to this recoiling of the gun, the shoulder of the shooter might get injured. But it cannot cause that much injury as compared to the bullet. Why? Because mass of the gun is high, so its acceleration is less. And mass of the bullet is very low, that's why its acceleration is very high. Okay? And because of the velocity and because of its structure, its pointedness, it's able to penetrate the body of a person or an animal, whatever, okay, or the target, right? So this recoiling of a gun explains Newton's third law of motion, okay? And now we've studied all the three laws of motion, and we know that all three are interconnected, okay? So keep studying, make your notes, and then we move forward to the law of conservation of momentum in the next class. Thank you.